Hey everyone, so today we are going to find the derivative of trig functions. So just the basic 6. We will eventually do the inverse ones, but those we'll do later. Alright, so pause the video and try the do now. The line y plus x equals k, where k is a constant, is a tangent to the graph of the function. What is the value of k? So if you notice, if you solve for y, the tangent line is negative x plus k. So that gives us a piece of information. We know that the slope is negative 1. So we need to know when is the slope of f negative 1. So we say 2x, so the slope, 2x minus 5, equals negative 1. So 2x equals 4, x equals 2. So we have the point 2, comma, and then what's the y value that goes along with that? If we plug f of 2 in, we get 4 minus 10 plus 2, negative 4. So they are it's tangent at the point 2, negative 4. So let's see, if we plug this into the line, we get negative 4 equals negative 2 plus k. So k has to be negative 2. All right. For what time is the velocity of the object 0? So v of t, we need the velocity. 6t minus 9. Set that equal to 0. It's pretty easy. 9 over 6, which is 3 over 2. C and C. Okay, so we talked about sketching the slope, right? So if I graph sine, so start by graphing sine. Alright, so there's my awkward graph of sine. So remember when we graph the derivative, y prime. Right, what do we know? Well, it has zeros at all the max and min points. So it hits here, 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 and here. And then we really want to pay attention to what is the slope. So over here, the slope is positive, right? It's an increasing function. Between these two, it's negative, positive, negative, positive. So that's just telling us where it's going to be. So negative, it's below the axis. And then it's above the axis, below the axis. So now look at this picture. What does this look like? Does this look like something that you know? Right? I hope it does. So I'm going to make another video, so go look at the other video now. And I'm going to show you there's a way to graph on the calculator the derivative. It's not it doesn't give you the actual answer, but it's a good way to look at the picture and you can really see and kind of convince yourself, okay, this is really the derivative. All right, so now we're going to do cosine. So look at your picture of cosine. I'm actually going to go through and show you the proof of this. It's a little complicated, but it's not that terrible. So we're going to start with what is cosine of a plus b. So you should have learned that last year. So that's cosine a, cosine b, minus sine a, sine b. Now we need that because whenever we find a derivative, we always go back to the definition, right? The limit as h approaches 0. We're doing cosine x, so cosine of x plus h minus cosine of x all over h. Okay. So what we're going to do is we're going to replace cosine of x plus h with this whole thing. So it's the limit as h approaches 0. I'm definitely going to run out of space. So we got cosine x, cosine h, minus sine x, sine h, minus our cosine x all over h. Okay? So I just replaced cosine of x plus h. So now what we're going to do is we're going to kind of put this and this together. We're going to make two fractions out of this. So it's the limit as h approaches 0. And we have cosine x, cosine h minus cosine x all over h. And then minus negative sine x sine h all over h. All right, so that's this part. So I separated it into two. Okay. Now, if you look at the top, this top one, I can factor out a cosine x, and I'm left with cosine of h minus 1. Okay. So we're going to use that over here. So we got the limit as h approaches 0. I've got cosine of x times cosine of h minus 1 all over h minus the limit h approaches 0. I have negative sine x sine h, but I'm going to do that. Okay, I'm going to put the h just over the one on the right, and you're allowed to do that because they're multiplying. So now let's look at what we know, right? We know that we did these when we did limits. H approaches 0, sine h over h. X approaches 0, sine x. That's a 1. And then negative sine x. Okay. This one on the left, we actually did that. If you remember, we multiplied the top and bottom by cosine h plus 1. Cosine h plus 1. And then that ended up turning into negative sine squared. So we end up with cosine x negative sine squared of h. Sorry, this is super messy. Negative sine squared of h all over h, which is cosine x sine h over h and negative sine of h. So I know it's super ridiculous. I apologize. So this gives us 0. Just kidding. That gives us 1. Right? Cosine of 0 is 1. This gives us 1. And then sine of 0 is 0. So that whole thing just cancels out. So the derivative of cosine is just negative sine. I know, that's a lot. I'm sorry. It's easier on the board at school. Okay, so now what I want you to do is, we know that the derivative of sine is cosine, the derivative of cosine is negative sine, right? So if y equals sine, y prime is cosine, and then we learned that if y is cosine, y prime is negative sine. So now what I want you to do is use the quotient rule and see if you can figure out what the derivative of tangent is. So we're going to do a quotient rule, right? So tan x prime equals, derivative of the top, cosine, so cosine times cosine, minus sine times negative sine all over cosine squared. This isn't very hard. Right? So that's cosine squared. We have a double negative and a negative, so plus sine squared over cosine squared. But what's cosine squared plus sine squared? That's 1. Now, you can leave it like that, but typically, we usually write the derivative of tangent is secant squared. Okay, so write these down. These are all your derivatives. You need to memorize these. The first 3 will be easy. We do the derivative of sine, cosine, tangent constantly. Secant, cosecant, cotan, they're a little harder. So just recognize that they're going to take a little bit of work. The hardest two, we do secant a lot too. We use that a lot. These 2 are going to be the ones that are the hardest to memorize. I am going to show you how we got that You could do the quotient rule. If you do the quotient rule with 1 over sine, 1 over cosine, cosine over sine, you can figure these out. But I think that's part of your homework, actually. Pretty sure your homework, you figure that out. Okay. So again, it's really just flat out memorization. That's all this lesson is. It's, okay, these are what their derivatives are, and now get really good at finding the derivative. So pause the video and do all of these on your own. All right. 1, derivative of x, derivative of sine is cosine. I am done. That is it. Number 2, product rule. X squared times sine x, derivative of the first, 2x times the second, plus the first, derivative of the second. Done. Number 3, derivative of the top times the bottom. I'm going to throw it in front. Minus the top, derivative of the bottom, which is just 1, all over the bottom squared. Last one, derivative of the first times the second, plus the first, derivative of the second. And I'm going to throw a negative. You can throw a negative wherever, as long as you have the negative. Find all points on the graph of f of x where the tangent line is horizontal. All right, so tangent line horizontal, right? That's where our derivative equals 0. So f prime is what? 1 plus cosine x. We're going to set that equal to 0. Where is cosine of x equal to -1? So that is pi, yep. So it's pi and then plus, right, 2 pi k. Every pi, it's going to be equal to -1. That's it. Right, this looks scary. That was easy. All right, now this is a little trickier. Find f double prime of pi over 4 if f of x is secant. So let's start with this. So f of x is secant. What is the derivative of secant? So this is why this is harder. The derivative is secant tan. So then when we take the derivative of this, we have a product rule, but be careful. This is my f, this is my g. So the derivative of the first, what's the derivative of secant? Secant tan. And then times the second. I'm going to do a different color. Times tan. Plus the first, secant, times the derivative of tangent, which is secant squared. So it's a little crazy here, right? So you get secant tan squared plus secant cubed. F double prime. So now we're going to plug in pi over 4. Well, secant of pi over 4 is cosine of pi over 4 is root 2 over 2. So secant is 2 over root 2. If I rationalize, 2 root 2 over 2, so it's just root 2. So it's root 2 times 1 squared, tan of pi over 4 is just 1, plus secant, again, is root 2 to the third. So we end up with root 2 plus cubed square root of 8, root 2 plus 2 root 2, 3 root 2. That's it. I know, it's kind of a lot. The plugging in is just like as long as you get there. They don't make a big deal. Like, you could have left it root 2 plus 8 root 8, but Depends on how good you are at this. All right, last one. Pause the video, try it on your own. All right, so we have L of t is 2 plus cosine. How does the length of the spring vary? I don't know what that's asking. I need to pause this video and go check that. An object hangs on a spring, making the spring 2 meters long in its equilibrium position. All right, so you got the spring, and it's 2 meters long. If the object is pulled down 1 meter and released, it will oscillate up and down. The length L of the spring after t seconds is modeled. So this is length, so this is position, right? So the velocity is just the derivative. So negative sine of t. What is the length? How does the length of the spring vary? I'm thinking, like, that's just asking this, the amplitude. So from 1 meter to 3 meters. I think that's what it's asking. At what position is the speed of the object a maximum? So what the speed, remember, is basically absolute value of velocity. So when is the velocity at a maximum? Ooh, so this is our velocity, right? Think of it, we can think of the graph of it. Where's the maximum point where this is at, where the speed is a maximum? So it's speed, so it actually doesn't matter. So it's pi over 2 or 3 pi over 2. Pi over 2 or 3 pi over 2 doesn't matter. And then what is the position at that point? So that's L of pi over 2 is 2 plus cosine of pi over 2. Cosine of pi over 2 is 0, so it's just 2. What is the maximum? At what position is the speed of the object at a maximum? So 2, when the position is 2. Find the acceleration. So acceleration is derivative of velocity. So negative cosine. At what position is the acceleration equal to 0? So when is the so start with acceleration equal to 0. When is cosine equal to 0? Cosine equals 0 at pi over 2, just like before. Oops, pi over 2, 3 pi over 2. At what position is the acceleration? Wow, I can't spell. Acceleration equal to 0. So then what's the position? So the position would be L. It's the same answer as letter C. So L of pi over 2. So at 2, it's at its maximum position. It's at its maximum speed, and the acceleration is 0. So that's interesting. And that is it. I know it's a crap ton of homework. I know. I want you. The purpose is for you to memorize. I really just want you to go through and do so many of the problems that you memorize it. That's why it's a lot. You have until Monday to do it. You have like 4 days to get this done. So I get it. I know it's a lot, but I need you to memorize these. It's really frustrating on this next test. Kids do bad when they don't have the memorization done. So, all right. I will talk to you later. Bye.